Hello, today we're going to solve a business problem for the telecommunications industry using Watson Data Platform. The tools we'll use are Data Catalog, Watson Machine Learning, and SPSS Modeler Flows. We'll use the catalog to locate the data we need for our problem and for our model. Then once we find that data, we'll pull it down into a project on Data Science Experience where we can use Watson Machine Learning and SPSS Modeler Flows to build a customer churn model. So we're going to find out which of our customers are likely to churn so we can focus our attention on them and not waste any resources on our loyal customers. So let's get started. Here we are on the catalog home screen. You can see we start off on browse, but we also might want to go over to usage. From usage, you can inspect the usage statistics of the various assets, and from access control, you can add collaborators. Watson Data Platform is a collaborative platform. You can control who participates, who has access to different kinds of assets, and here we'll add Armand Ruiz as an admin. That way, he has administrator privileges on our catalog, and he can participate in this as well. You can see that we've enforced governance policies on this project, so we control who has access to our data assets and what kind of access they have. Now we want to populate this catalog with some data assets. That way we can bring this data down into our project. Since we're building a customer churn model and we've got the data on our local machine, we'll hit Add Data and you can see how easy it is to bring that data into your catalog. Notice all of the files there. Now we'll use some tags. Tags make your data searchable and it makes it easier for your collaborators and for yourself to find your assets later. Tags we'll go with are churn, customer, and SPSS. After clicking the Add button, we'll also want to add members. Since we've enforced governance policies on this data catalog, it's important that we permission our assets appropriately, and so we've added Armand Ruiz to these assets as well. Next, we'll provide a description for our reference and our colleague's reference later, and consider adding a classification. Classification is helpful if you have sensitive, personal, or confidential information, and you need to flag this in the catalog or enforce some kinds of governance policies on the basis of this classification. Suppose we don't want to make one of the assets available, we just click X and then add, and you can see that all three files are loading into E2E. That's the catalog we've developed here. Let's use the tags to find the data that we've just uploaded. You can click the name of any tag and it will generate all of the assets that have that tag associated with them. You can see here churn, customer, and new customer churn. We check all of them and press Add to Project. Now, Watson Data Platform will make those data sets available to you in your project. Just click Go to Project and you'll be brought to the home screen of the project that you just associated those data assets with. You can see here on the sidebar panel on the right-hand side, there are multiple ways to add data. And you can also navigate through your catalogs from within the project's interface as well. We chose to do it from the Data Catalog UI as it made more sense for our workflow. Now that we've pulled the data from Data Catalog into a project on DSX, we're ready to begin the modeling process. The tool we'll use is SPSS Modeler Flow, a powerful and flexible framework for building models on the Watson Data Platform. You can build new models from scratch, but you also have other options, such as from file and from example. If you have any existing SPSS modeler files on your machine, you can upload them there, and you also can take advantage of a pre-designed architecture by the SPSS modeler team in order to help you get started. We choose IBM SPSS Modeler for our runtime and click Create. When you create a new flow, your data assets will be available to you on the sidebar panel as data nodes. You simply drag and drop these onto the flow canvas and you'll be able to begin modeling. First asset we'll bring in is the customer CSV. This contains information about all of the attributes for our customers, such as their age, their gender, their marital status, and any other information that this company has collected about their customers. We'll also need to bring in the churn data and merge them together. That file contains information for each historical customer about whether or not they've churned. Taken together, we'll be able to build a model on these data. We'll go back to the sidebar panel, grab the churn CSV, and drop it underneath the other data. Suppose that before we merge the data sets, we want to take a preview to make sure that this is in fact the data that we suspect it is. Well, it's pretty easy to do that as well directly from within this interface. all you do is navigate over to the node and click Preview. Notice that here we have information which contains the customer ID and whether or not they've churned. It's pretty evident from this data that we'll need to merge both datasets on the customer ID column. Now let's preview the other dataset, the customer attributes, just to make sure that we've got the fields that we expect and we've got the ID column that we can merge on. Head over to Customer and click Preview as well. The customer data also has an ID field, but also contains some of the other information we spoke about earlier, such as the gender, the income, the marital status, and so on. Left-hand side, we have the node palette, which contains all of the familiar nodes from SPSS Modeler. What we're interested in is record operations and the merge node. The merge node is pretty intelligent, so it'll know if there are overlapping columns or an ID column. Makes it pretty easy to join that data together. And after we join the data, we'll plot a histogram with one of the graphs nodes. Let's open it up and configure the graph. The field we'll focus on is age. So since we're plotting a histogram, we need continuous values. So we'll choose age for the continuous field, and then we'll color it by churn. That way we'll have a histogram of the age, which is colored by churn, and we'll give it a title, something like churn and age seems all right, and hit OK. Head over to the graph node and click Run. Run will execute the entire flow that currently terminates in this age histogram. After the flow terminates, it'll generate some kind of output that you can access here on the side. You can see your histogram of age number 1, and there it is, the histogram of age, which is colored by our churn values. Now these graphs are highly customizable, and we have many graph options as well. You can include graphs in your analysis and in your modeling process along the way. Now we'll find the SPSS type node so that we can specify which of the fields in our dataset we want to use as our target, as the label we're actually trying to model, and which of the fields we want to use as our attributes or our predictors. We already know that we're trying to model churn, and that our predictors are all those other features that we've spoken about a few times. So click Add, and here you can see churn. So it's currently just a string with no other information about it. We're going to flag it as a label. The way we do this is pretty simple. We just select the field, and what we want to do is change the role. Currently the role is input. That'll be one of the inputs to our model, but actually it's the target. You have some other options as well, but for churn, it's target. So we'll click target, and that's it. Some other things you might want to do, for example, the ID columns. The ID column really doesn't contain any predictive information, presumably, so the role for that will change to ID. Now that we've configured the different types for our model, we're ready to add a modeling node. The algorithm that we'll use is a popular decision tree algorithm available on SPSS called C5. The C5 model is a binary decision tree model, so it's going to try to find the best way to break down your data into different groups such that it can form rules about the data which are predictive of whether or not an individual example will result in a churn or whether they'll stick with the firm. Building the model is as easy as following the simple pattern. Just run the flow. After the flow executes, you can see here that we've got a trained model in churn. You can click this to view information about the model. You can see it's a binary decision tree. You can see the depth of the tree, other information about the predictor importance. Notice that status, which is marital status, is the most predictive feature for this dataset in our model. We also can do other things like view the rules, view the diagram itself, and so on. After we notice that status seems to be very predictive of churn, maybe we want to dig a little bit deeper with another visualization. This time we'll take another look at the distribution of churn with respect to status. Just grab a distribution node and drop it there on the canvas. Connect the data that's been merged and configure your node. The field we'll look at is churn, but this time we want to take a look at it by status. Remember that all you need to do is execute the flow and your visualizations will appear in the sidebar panel. What we'll do here again is we'll give it a custom name. This time we'll choose something like churn and status. That makes sense. And go back over to our settings and click OK. Let's run this flow. After the execution of the flow completes, you'll be able to view the graph again in your outputs. Take a look at churn and status. Notice here that if your churn is false, if you haven't churned, then you're much more likely to be married than in the case of customers who have churned. Now that we've built this model on the historical data that we have, we're ready to make predictions on new data. Remember at the beginning that we brought in a file called new customer churn data, and we'll use the model that we have here, that C5 decision tree model, to generate predictions for the new data. Head back over to the data on the side and find new customer churn and drop that data on the canvas. Previously, we were feeding in our original data from that type node into our model, but we're going to break that connection. The reason is we want to connect our new customer churn data to the model. This is simple and intuitive. Just drag the pointers to connect the two nodes. Now we can preview the new data as we did previously just by clicking preview, make sure everything's all right, and close the preview. Now what we want to do is head over to the outputs nodes. This way we can export the data as a table after we've made new predictions. This way we'll generate new fields in our dataset and we'll be able to compare the results to what actually happened later. After we drop the final two nodes, we'll just recenter our flow and take another look. Running one final time, it'll execute the entire stream, and now we'll be able to view our table output. If we pan over all the way to the right, we'll be able to see the prediction for these new customers, a true or false whether or not they've churned, and also a predicted probability in the interval 0 to 1 to tell us how confident our model is about whether or not they've churned. We've brought in the data from Data Catalog and built a model in DSX with the SPSS modeler flow. We're ready to save the model, and we'll need Watson Machine Learning to do that. What you do is you can click Table and Save Model, and since we already didn't have a machine learning service associated with this project, it'll prompt us to set up a new one, which we can do for free, or we can associate an existing service with this project. And since I've already got one, I'll head over to Existing, click the one I have, and press Select. Now this SPSS modeler model is available in your Watson Machine Learning repo wherever you make use of it, whether that's with our open source Python client or whether you want to deploy this model graphically. You can come back and view your graphs or your tables at any time, or edit this flow and build, save, and deploy new versions of your models. Let's head back to the projects and take a look where our model is. Scrolling down to Models and click My Churn Model. From here, you'll be able to see the model that you've just saved to your Watson Machine Learning repo. Stay tuned for more videos and tutorials about deployments, continuous learning, and other ways to expose your model as an API and consume them in applications. In this video, we populated data into a data catalog, added permissions and governance, pulled that data into a DSX project, built a model with SPSS modeler flows, and then saved that model to our Watson Machine Learning repo.